House Robber 2 on Leet Code. A professional robber plans to rob houses along a street, but these houses are arranged in a circle. That means the first and last house are direct neighbors, just like every other adjacent pair. The robber's rule is simple. Never rob two houses right next to each other, or the alarms go off. Given an array of integers representing the money in each house, we need to return the maximum amount the robber can steal. Here we have 5 houses with values 2, 7, 9, 3, and 1. Notice that house 0 and house 4 share a border in this circular layout. Our job is to find the most profitable robbery plan that respects this circular constraint. The key insight is that the circular constraint only affects 2 houses. House 0 and house n-1 are neighbors, so we cannot rob both in the same plan. We already know how to solve the simpler linear version of this problem with dynamic programming. We can exploit that by splitting the circular problem into 2 separate linear passes. In pass 1, we consider houses 0 through n-2, simply ignoring the last house. In pass 2, we consider houses 1 through n-1, ignoring the first house. Because every valid solution must exclude either the first or the last house, the answer is the maximum result from these 2 linear passes. The workhorse for both passes is the standard linear house robber recurrence. We define DPI as the maximum money we can steal considering only houses up to index I. The formula is DPI equals the maximum of DPI minus 1, meaning we skip house I, or DPI minus 2 plus RI, meaning we rob house I using the best we could do 2 steps back. For the base cases, DP0 is simply R0, and DP1 is the maximum of R0 and R1, choosing whichever of the first 2 houses has more money. We return DP at the last index. Pass 1 runs the DP on the first 4 houses with values 2, 7, 9, and 3, excluding the last house entirely. DP0 is 2 and DP1 is max of 2 and 7, giving 7. At index 2, we compare DP1 equals 7 against DP0 plus 9 equals 11. 11 wins, so DP2 is 11. We are robbing house 0 and house 2. At index 3, we compare DP2 equals 11 against DP1 plus 3 equals 10. 11 still wins, so DP3 is 11. Pass 1 returns 11. Pass 2 runs the DP on the last 4 houses with values 7, 9, 3, and 1, excluding the first house. Again, we use local indices from 0. DP0 is 7 and DP1 is max of 7 and 9, giving 9. At index 2, we compare DP1 equals 9 against DP0 plus 3 equals 10. 10 wins, so DP2 is 10. At index 3, we compare DP2 equals 10 against DP1 plus 1 equals 10. Both equal 10, so DP3 is 10. Pass 2 returns 10. We now have both results. Pass 1, which excluded the last house, returned 11. Pass 2, which excluded the first house, returned 10. The final answer is the maximum of these two, 11. This corresponds to robbing house 0, which has $2, and house 2, which has $9, for a combined total of 11. The circular constraint is satisfied. We never robbed 2 adjacent houses, and houses 0 and 4, which are circular neighbors, are not both robbed. Here is the complete Python solution. We define a helper linear rob that accepts a subarray and runs the standard DP, returning the best steal for a linear arrangement. The helper handles the single-element edge case, sets the 2 base cases, then fills the array with the recurrence and returns the last element. The main rob function handles the edge case of a single house, then calls linear rob twice, once on nums from index 0 to n-2, and once on nums from index 1 to n-1. We return the maximum of the 2. Time complexity is O of n for 2 linear passes. Space is O of n for the DP arrays.